Hello everyone. In this lecture, we will discuss about the GATE and IES questions on graphical method topic. First question is, the business owners Shweta and Ashok run their business in two different states. Each of them independent of the other, produces two products A and B, sells them at 2000 rupees per kg and 3000 per kg, and uses linear programming to determine the optimal quantity of A and B to maximize their respective daily revenue. Their constraints are, first constraint is, for each business owner, the production process is such that the daily production of A has to be at least as much as B, and upper limit for production of B is 10 kg per day. Second constraint is, the respective state regulations restrict Shweta's production of A to less than 20 kg per day and Ashok's production of A to less than 15 kg per day. The demand of both A and B in both these states is very high and everything produced is sold. The absolute value of the difference in daily revenue of Shweta and Ashok is dash 1000 rupees. So this question is given in GATE 2020. And let's see the solution. For this, first we have to develop the linear programming model. For this, we have to formulate the objective function. We know that the objective is, it should be maximum profit, maximum sales, minimum cost, and minimum production time, etc. So, in the given data, we have to observe the sentences regarding these words. And here, I identified that one. Shweta and Ashok produces two products A and B, sells them at 2000 rupees per kg and 3000 rupees per kg respectively. So, objective function is, that is, let us consider Z, it should be equal to 2000 into product A plus 3000 into product B. Let us consider A equal to x1 and B equal to x2. Then our objective function, that is Z equal to 2000 x1 plus 3000 x2. So next we have to frame the constraints. So first constraint is, for each business owner, the production process is such that the daily production of A has to be at least as much as B, and upper limit for production B is 10 kg per day. So constraints for Shweta's and Ashok's production, x1 is greater than or equal to the x2 and x2 is less than or equal to 10. Let's see the second constraint, that is, the respective state regulations restrict Shweta's production of A to less than 20 kg per day and Ashok's production of A to less than 50 kg per day. So constraints for Shweta's production is, x1 is less than or equal to 20 and constraints for Ashok production is x1 less than or equal to the 15. Next step is, plot the constraints on graph paper and find the feasible region. So first we have to find the feasible region for Shweta's business. For this, first we have to convert the constraint into equation and also find the coordinates for the respective constraints and plot the lines on the graph paper. So these are the constraint lines for the respective constraints. So next we have to find the region for each constraints based on the inequality symbol. So first we have to observe the first constraint, that is x1 is greater than or equal to x2. For this, consider the region is below the line. So y means, if x2 equal to 2, then x1 should be greater than or equal to 2, which means it should be more than the 2, 3, 4, so on. Similarly, if x2 equal to the 10, then x1 should be greater than or equal to the 10, which means 10, 11, so 12, like that, so on. So here we have to consider the region is below the line. Similarly, second constraint is the x2 is less than or equal to 10. So here also have to consider the region is below the line. And third constraint is x1 is less than or equal to the 20. So which means here also have to consider the region is below the line. So common area, that is the feasible region, is OABC. And coordinates for the OABC are 0, 0, 20, 0, 20, 10 and 10, 10. Then we have to substitute these values in the objective function. Then we will get the values for the objective function, that is z equal to 40,000 at A, z equal to 70,000 at B, z equal to 50,000 at C. Similarly, we have to find the feasible region for Ashok's production. And here feasible region is OABC, and we have to substitute these values, these coordinates values in the objective function. Then we will get the z values are 30,000 at A, 60,000 at B, 50,000 at C. So here maximum z is 70,000 at B for the Shweta's production, and maximum z is 60,000 at B for Ashok's production. So next we have to find the absolute value of the difference in daily revenues of Shweta's and Ashok's production. So we have to find the difference between the maximum revenues of the Shweta's and Ashok's production difference, that is 70,000 minus 60,000. We will get the solution is 10,000. So next problem is, consider the following linear programming problem. Maximize z equal to 3x1 plus 2x2 and subjected to constraints are x1 is less than or equal to 4, x2 is less than or equal to 6, 3x1 plus x2 less than or equal to 18, x1 and x2 greater than or equal to 0. So this problem is given in 2009 GATE exam. Let's see the solution is, first we have to convert the constraints into the equations and also have to find the coordinates. After that one, we have to plot the lines and make the region based on the inequality symbol for the each constraints, and after that one we have to find the feasible region. So we know that one, this type of model is the having the unique optimal solution. Next, observe the another question. A feasible solution to the linear programming problem should be. So options is satisfy the problem constraints, optimize the objective function, satisfy the problem constraints or non-negativity restrictions, satisfy the non-negativity restrictions. So this question is given in IES 1994, and we know that one feasible region is set of values which satisfy the all the constraints and also non-negativity constraints. So option should be the C. And next to see the next question is, in case of solution of linear programming problem using graphical method, if the constraint line of the one of the non-redundant constraint is parallel to the objective function line, then it indicate option A is an infeasible solution, a degenerate solution, an unbounded solution, a multiple number of optimal solution. We already discussed in the lecture number 7. So when the constraint is parallel to the objective function line, so it will the problem is having the multiple number of solutions. So option is the D.